Hola, buenas tardes. Buenas tardes. Bueno, muchas gracias por estar aquí. Ahora vamos a seguir hablando de transición justa. We will keep going of fair or just transition. And after having such a, we could say, more political event, I think that it's a pleasure to have now I would say a more technical focused presentation about Google is Marsden Hannah. We had the pleasure to have you here the other day, so thank you very much for coming again, and we are looking to listening to you. Thank you.
Thank you so much, and thank you for the opportunity to join you today. My name is Marsden Hannah. I'm part of the data center team at Google. I lead sustainability policy initiatives. And I want to talk a little bit today about some of the work we're doing to promote sustainability. So at Google, we know that climate change is an urgent global problem. It's a defining issue of our time, and we need to take urgent action. So we're addressing this by trying to build sustainability into everything that we do through all of our operations. But I want to talk really specifically about three aspects of our focus. The first is on data centers. We own and operate large data centers. Second is we purchase the output of a significant amount of renewable energy for our operations to run our operations in a green manner. And lastly, we have several applications of technology, Google technology, to help solve climate change. And I'm going to talk about one in particular, but let's dive in. So on the data center component, so you might wonder, why does Google care about electricity? Why does Google use a lot of electricity? Well, the answer is that every time you do a Google search, you're using a small amount of electricity. And there's trillions of searches over the course of every year, and these add up. Whenever you're watching YouTube or streaming a YouTube video, that's coming out of a Google data center and is using electricity. Every day, there's more than 1 billion hours of YouTube that are watched, and every minute people upload 400 hours of video to the site. So it's a really tremendous amount of video, and all of these videos add up to a significant amount of electricity. So we now have 9 products that have over 1 billion users around the world. So Search, Android, Chrome, Maps, Google Play, YouTube, Gmail, Drive, and Photos. So all of these we run on the physical infrastructure of a data center. So to give you a sense of what this looks like, since it's hard to imagine, this is our data center in Iowa. You can see that this is a 4-story building right here. And this is a parking lot. So this is a really, really large facility. This building is the entire site is over 230 football fields in scale. So this is really industrial scale computing. This is not a couple computers in a room. It's really large. And if you look at the inside, this is what it looks like. It's just rows and rows of computers and machines that are doing all of the storage. They're doing all the compute jobs, all the routing that's actually allowing Google to operate. So we have 16 of these data centers around the world. We have, I think, 5 now in Europe, 2 in Asia, 1 in Latin America, and a number in the US. So all of these put together make up a pretty substantial amount of electricity. We used 10 terawatt hours of electricity in 2018. So that's twice as much as the city of San Francisco consumes in a year. So it's a very substantial amount. So, but it's been growing at a very substantial rate. You can see, if you look at the last few years, only 8 years ago we were consuming 3 terawatt hours, and now we're triple that size just since 2011. It's continued to grow at between 20 to 30% every year, and we foresee that continuing for some time. So we're very, very focused on managing our electricity consumption from an operational standpoint, from a financial and cost standpoint, and of course from a sustainability standpoint. This is the largest component of our carbon footprint as a company, so we really care about managing it. Before we green the electricity, though, the very first thing we want to do is make sure we're running as efficiently as possible. So we've spent a lot of time over the last 10 years or so making sure that when we design the data centers and the way we operate the data centers uses absolutely the least amount of power that is possible. So we do this through a number of ways. One, we have smart controls over the data center that operate the machines in a way that's intended to minimize the electricity usage. We spend a lot of time focusing on design of the facilities. We manufacture a lot of our own hardware, and that hardware is more efficient than a lot of industry standard hardware, so we're able to get more computing. And in fact, over the last 10 years, we've been able to we now get 7 times as much computing power out of the same unit of electricity as we did long ago. So it's a big focus for us. We use, wherever we're able, we like to cool using natural resources. So for example, our data center in Finland uses free air cooling, so we don't have to spend electricity. When it's cold, we bring in cold air to cool the facility, and then when we release it back. So a lot of work has gone into this. This is a measure of efficiency. So the data center sector has developed a metric that's called power usage effectiveness, and what this is the total facility load on the top divided by the electricity used for computing, right? So if the number is 1, that's perfect, right? So 100% of the electricity is going into machines, into compute resources. If the number is 2, it means you have 50% of electricity going to machines, 50% going to just building operations and facilities and overhead, essentially. So you want that number to be as low as possible. So we've now, over the course of the last 10 years, been able to drive it down year over year over year to a point where we're finally at only 11% of electricity is going into overhead for the building. So we're very proud of that. A lot of work went in. But of course, we still consume, as I mentioned, a significant amount of electricity. So we do want to make sure that electricity is green. We want to be carbon neutral. We want to be climate friendly. So what we've done over the last, since 2010, is purchase significant amounts of renewable energy. So we'll enter into a contract with a wind farm to purchase 100% of the output of the facility. We don't invest, we don't own it, we just purchase all the electricity. And we've now done more than 5 gigawatts of renewable energy projects around the world. You can see the blue is wind and the yellow is solar, obviously. You may notice that these correlate to areas where these resources are strong. We are agnostic between which technology. We just want it to be clean and we want it to be the cheapest. So in the southeastern United States, solar is very cheap. In the Midwest, wind is very cheap. Same in Norway. You have a lot of really, really cost-effective wind resources. So we've prioritized it that way. And we were very excited to announce that in 2017, we achieved our goal of matching 100% of our electricity usage with renewable energy. And we did that again in 2018. And we are committed to continuing on this path and continuing to match 100% renewable. And what this means, to be clear, is that this is an annual and a global goal. So over the course of the entire year, we're purchasing the same number of megawatt hours of renewable energy as we are consuming. It doesn't mean in every minute of every day there's a renewable resource powering the data center, which I'll talk about a little bit. But and part of why we do this, in addition to the sustainability aspect, is in many places this is actually the cheapest option. This is the most cost-effective energy you can buy. This is a chart showing the prices of renewable energy for wind and solar over time. It used to be in the $180 megawatt hour, and it's really come down sub $50 in a lot of markets, which is very cost competitive. So this is actually a good business decision too. It's not just about sustainability, it's about saving money for our operations. I'm going very fast, I know, I'm sorry, but I have a lot of slides. So when we think about this, there's several principles that we apply when we purchase renewable energy. We want to be having a material impact. So that means we only buy from newly constructed projects that are built for Google. We don't take existing projects that are online and divert them to power Google. We want to be adding new renewable energy to the grid and contributing to decarbonization. we always buy both the physical electricity and any environmental attributes that are associated with it, so renewable energy certificates. We want to do this on the grids where we operate. We don't want to be, to the greatest extent we can, we want to be doing this where the actual consumption is. And as much as possible, we want to have it delivered directly to the data center. So we're very excited about this. We've done a lot of work. We're very pleased to be a leader in this area. But we also know that if we're truly going to decarbonize the economy, if we're truly going to get to zero carbon, it can't just be Google that's doing this. You shouldn't have to be a Fortune 500 company to be able to purchase clean energy for your operations. So we've partnered with several organizations around the world that are really focused on creating access to for any company in any geography to be able to purchase renewable energy, because we know that that's going to have to be a part of the solution, and it's working actually in a lot of markets right now. This is the last few years of companies that have purchased renewable energy in total, and you can see it's really going up. And 2019 right now is actually about as large as 2018. So I think there's been about 40 gigawatts of renewable energy that have been purchased. There's an organization called the RE100 campaign that is a group of 200 companies, all of which are committed to purchasing 100% renewables for their operations. And if all 200 of those companies were to achieve that goal, if they all got to 100%, that would create 97 gigawatts of new renewable energy. So to put that in perspective, 97 gigawatts is about the same as all of the wind energy installed in the United States today. So it's a really substantial amount for only 200 companies. So think what we could do if it was 500 or 5,000 or 50,000 companies. So it's something we really believe that consumers wanting to purchase clean power is a really important opportunity. This is another organization in the United States that is working on the same thing, Renewable Energy Buyers Alliance. I'm going to keep going. So we also know that the annual match concept, where we're purchasing the same amount of electricity over the course of a year, is not really the way the grid works. The grid is balanced in a minute-by-minute basis, right? So we know that if we're really going to get to true zero carbon, we need to think about the time of production, and we need to look at how do we get to 24-hour a day, 7-day a week, zero carbon energy. So this is an example of energy production against our consumption at the Chile data center that we have. You can see that this line is the electricity consumption. This is the 24 hours of the day. And we have a solar project here which comes online, produces a lot of energy, and goes offline. And then this is the clean energy on the grid. So Chile has a lot of hydro resources. So the grid is very clean already. So we only have a small amount here of fossil-fired power. So this is a good way to think about, are we truly clean or not? We are 100% clean in these hours, but we're not 100% in these hours. So if we take that and we look at every hour of the entire year. So this is, on the x-axis, you have January through December, and then here you have midnight, noon, evening. So this is the course of a day, and the greener the image, the more carbon-free it is, and the browner, the less carbon-free. So this is our North Carolina data center. We have a solar project that's powering the facility there. So you can see, because the solar is on during the day, we're pretty green in that area. But over the course of the year, we're only 67%. So we're not 100% carbon-free. We need to get better. We need to go do more. It's very different in every data center, though. So this is a picture of Finland, the Finland data center. Finland has a lot of nuclear, has a lot of hydro resources. So the underlying grid is very, very clean. We also have a lot of wind energy. So we're 97% carbon-free in Finland, which is very exciting. But then other markets are not so good. So this is our data center in Taiwan, which you can see is very brown. Especially here, they turned off the nuclear plants for several months, and so it got worse. So we have a long way to go in some of these sites, but we do know that renewable energy is making a big difference. This is a really, really good start. So this is an example of our Iowa data center without any Google renewable energy purchasing. This is just the grid. This is what the grid looks like in every hour of the year. And then when you add in Google's purchasing from wind energy, we go from 17% to 74%. So we know that it's making a big difference. We know that this is a great first step, so we're really committed to continuing, but we want to get to 100%. So there's a lot we're doing. We're trying to think of other transactions. We know this is going to be about different technologies. It's going to be about policies that help green the grid overall, and it's going to be about just finding ways to come up with unique transactions that get us to 100% carbon free. So I know I'm flying through this, but I want to talk lastly about some of the technology, one in particular of the technology applications that Google has focused on as a way to help mitigate climate change. We have several fairly interesting projects which I'm not going to talk about, but I'll mention. One of which is we're using artificial intelligence to help improve flood forecasting in India, so that as the climate becomes more unpredictable, we can use artificial intelligence to understand where floods will happen, when they will happen, on a more granular basis, and then provide that information to folks on the ground so that they can adapt to a changing climate. So there's several applications like that we're excited about, but this one I'm particularly excited about. This is a project that our Geo team has worked on. This is the part of the company that works on Google Maps and Google Earth. And I think what they realized was we're sitting on all this information about transportation, about buildings, and about solar rooftop potential. So how can we use that information for good? So what they've developed is a product called the Environmental Insights Explorer. And what this does is it takes information about buildings from Google Maps, and then transportation emissions based on the mode of transport in a particular city, and then the average emissions of a particular mode, and it helps create a picture of how much emissions a given city is producing from these different types. The last piece is solar rooftop potential. So we take shading of, we have a 3D model of a city that we use for Google Maps, and then we overlay a solar irradiance model, and you can see how much would you save or how much could you produce if you put solar on your rooftop. And then we aggregate that out to a full city level. And so the intent of this is we want to make this, we are making this tool available to city planners who are focused on reducing their emissions. They want to develop climate action plans for their city. They want to find a way to reduce emissions. The first thing you need to do before you reduce is you have to measure. You have to know how much you're producing so that you can develop a plan to reduce, and then you can do it. So we're really solving that first part on measurement. Just to give a little bit of a more granular picture, this is what the tool, this is, by the way, if you just go to insights.sustainability.google.com, this is available in public. But this is an example of Victoria, Canada, and what you would see if you were to click in. So we have a model of the city, and we know what the building sizes are based on the mapping data, and then we know how many are residential, non-residential, and what your total emissions are from each sector. So with this information, if a city wanted to develop this themselves, it's often very, very expensive. It takes 3 to 4 years. It's hundreds of thousands of dollars to do this, but it's easy for us to surface this information for free. So they can take this information and then say, what if I do a LED lighting program in my city to reduce consumption of homes, electricity consumption of homes by 10%, and they'll know how much that can help. So things like that. If we go to transportation, this is really interesting to me. This aggregates all of the Google Maps data about phones and traffic around the city, and you can see we have the total distance traveled by type of transit. So in this case, in Victoria, mostly cars, some walking, some biking. And what's particularly interesting here is you can say, if I convert my my fleet of city buses to electric vehicles, I can know very, very quickly how much that will save me and develop a quick action plan. Or if I put in bike lanes in my city, and use that to increase bike trips by 50%. I'll know that I'll take some out of this category and up into here, and there's scenario modeling tools that will allow the city planners to do this kind of thing. So this is just a screenshot of the solar rooftop potential. So you can see here the darker the area, the shadier it is, the more orange it is, the sunnier it is. And we can see that this city has a substantial potential for rooftop solar for the citizens. So one interesting application of this, and this is my last slide, is the city of San Jose used this tool to set a target that they want to be the first city that has a gigawatt of rooftop solar installed in their city. And they were, which is a lot, that's a tremendous amount of electricity. So they were able to use this tool to estimate the total potential and know with reasonable certainty that this is an achievable goal. And now they're implementing programs to increase solar rooftop penetration in their city. So it's very exciting. We announced on Tuesday that this tool is now available in 100 cities. It used to be, we launched it last year at the Global Climate Action Summit with only 6 cities, but now it's expanded to 100. And we're hoping to expand to more. So it's exciting times. And that's all I have, so happy to take any questions if there's time. Yeah. Great. No questions. One, there we go.
Hello, I have in fact 2 questions. The first is, are you offsetting your emissions somehow? For example, we know that Ecosia, another search engine, is having substantial projects for planting trees. And the second question is, what kind of granularity we can see with such application? Can you go to the level of a single house and tell what is its CO2 emissions?
So for the second question, you can do that for the solar rooftop potential. You can go to an individual house. I don't think for the building's emissions that it goes, hope everything's okay. I don't think for the building emissions that it goes to a single building. We want to make sure we're protecting users' privacy. We wouldn't want people to feel like some information is being exposed about them. But for rooftop, that's just based on a satellite picture. So that is available for individual houses. For the first question, so we're managing the carbon footprint of the company in a couple ways. The first thing we do is try to reduce or use as little energy as possible. So we're focusing a lot on efficiency. And then we buy all these renewables to match, right? So we're able to offset the carbon emissions of the facility by powering it with renewable energy. There is a portion where, of course, we're not able to, or we're not 100% carbon free. Even though we might be 100% renewable, we might not be 100% carbon free. So for those emissions, we do buy offsets, and we have been doing that since 2007. So we have been carbon neutral as a company since 2007.
Very much. Thanks a lot. No, just one question regarding Google Maps.
Yeah.
It's very interesting because it makes possible to know how many CO2 emissions we could produce by using the different transport. But are you considering perhaps to integrate to some extent in every city if the buses are electric, or could that be possible, or is something that you don't consider and perhaps other companies could do on your application?
Yeah. That should be included because we're able to know the mode of transport. So the first thing that the tool does is it measures it's totally anonymized data, but it measures what trips people are taking from where to where in what kind of vehicle. And so we know so many trips are by electric rail, so many trips are by metro, so many trips are walking, some are single-use vehicles. So if a city's bus fleet is already electric, that should be reflected in the way that we're able to quantify it in the data. Yeah.
So
Okay.
thank you very
Okay.
much.
Thank
Thanks
you.
a lot. Very
Yeah, thank you.
interesting.
Thanks very much.